Hello and welcome to Module 3.4, Intercepts of Graphs. Our objective today is that I can identify the intercepts of functions in intervals where functions are positive and negative. Our vocabulary for today. An x-intercept is going to be the coordinate where the line of a graph crosses the x-axis. The y-intercept is going to be the coordinate where the line crosses the y-axis. A graph is going to be positive when it lies above the x-axis, and a graph is going to be negative when the graph lies below the x-axis. Root and zero are both terms that we're going to be using in the future. The root is any value that makes the equation true, and a zero is the x-intercept of the graph. Zeros will specifically be coming up when we are solving quadratic equations later on in second semester. Now, let's take a look at these. We're going to find our intercepts. We're going to find when is it positive and when is it negative. So letter A, we're going to start with our x-intercepts, so places that we are crossing the x-axis. I have one right there, I have one right there, and I have one right there. Now, when I approximate these, we're going to write them as x equals. So x is going to equal negative, we're going to approximate as negative 4.2. We're going to say x is equal to negative 2.2, and x is equal to 0.4. Now, if I want to find my y-intercept, it's where y is crossing the x-axis, and it looks like it's right there at y equals negative 2. All right, now if I'm looking to see when is my graph going to be positive, it's going to be in this range and this range. So positive, all right, x will be between, it's going to be between negative 4.2 and negative 2.2, or x is going to be greater than 0.4. Where is this graph going to be negative? Well, it's this part right here, so negative x will be less than negative 4.2, and it'll be this interval right here, so it'll be x is between negative 2.2 and 0.4. All right, so let's look at letter B. A little bit cleaner because it is just a straight line. My x-intercept is right here. X is equal to 1, 2, 3. My y-intercept is going to be right up here. X is going to be, or y is going to be equal to 1, 2, 3, 4, 5, 6. So y equals 6. When is this graph going to be positive? It's this section right here. So it's going to be when x is less than 3. Now that might be a little counterintuitive that we're saying x is going to be less than a number and we're talking about it being positive, but we're thinking about the output. If we think back to our function vocabulary, the output of this function is positive, meaning it's above 0. The input that we're putting in is going to be these values of x that are less than 3. So if I looked at, x is 1, we get a positive value. X is negative 1, we get a positive value. X is 0, we get a positive value, right? These are all x values that are going to give us a positive outcome with our y. Now, when we look for our negative sections, we are going to be this section to the right here, and so that's going to be x is greater than 3. Now let's look at letter C. We have a flip. We have a positive graph now, positive slopes. We have an x-intercept there. So x is going to be equal to -2. Our y-intercept is right there. Our y value is at positive 1, 2, 3, 4. Okay. We are going to be positive when x is going to be greater than -2, right? It's this part of the interval right there. We're going to be negative when x is less than -2. All right. Now, as we're looking at our graphs here and we're looking at our interactions between our x-intercept and our y-intercept, when we are crossing the y-axis right here for our y-intercept, right, we're saying that our y value is 4. Well, at the beginning, I said our intercepts are coordinates. So what is the coordinate of that point? It's going to be 0, 4. So when we're writing in intercepts and we're finding them, we want to write them, or we want to see that the interaction here is our y value is 4, but the x value is 0, because that's when we are crossing over our y-axis. Same for down below. When our x value is going to be -2, our y value is 0. That is where we are crossing over our x-axis. All right, so there are 3 you-try problems. One of them is a table, and I want you to try that one on your own. All right, if we look at letter D, we have x-intercepts at -4 and 3, and I have a y-intercept at -12. I am going to be positive when x is going to be less than -4 or x is greater than 3. I'm going to be negative when x is between -4 and 3. All right. Letter E, another quadratic. So we have x-intercepts. X equals 1. X equals 4. Those are roots of that equation. My y-intercept is way down here. Y is equal to -1, 2, 3, -4. I'm going to be positive in this interval here. So x is between 1 and 4. I'm going to be negative when x is less than 1 or when x is greater than 4. And if I look at my table, my y-intercept, remember, was when our x value is going to be equal to 0. So this is my y-intercept right here. We are starting at 80 when x value is 0, and my x-intercept is 40, 0. That is when I'm crossing my x-axis. So that is when my y value is going to be 0. So if we go back to the top of the page to our definitions, for x-axis, I want to add in when y is equal to 0. And my y-axis, my y-intercept, is when x equals 0. So when we substitute in, we are substituting 0 into the opposite in order to find the intercept. So if we're trying to find our y-intercept, we put in 0 for x. When we're trying to find our x-intercept, we put in 0 for y. We're going to turn to the next page, please. And we are going to estimate x and y intercepts of each graph or table, and then interpret the meaning in the context of the situation, the meaning of those intercepts. So we're going to start with our y-intercept, which is right here. So our y-intercept, we've got y equals 4, and our units here are feet. And what is it given? What is the meaning of this in our context here? Well, this says the graph shows the height of a kicked ball over time. So when time is 0, the height of the ball is 4 feet. So that is the starting height of the ball. Now, what is my x-intercept? My x-intercept is right down here at 9. So it's x equals 9, and we're measuring time in seconds. And this is representing when the ball has reached 0 height. So that would be when the ball lands. Okay, so 9 seconds is when the ball lands. All right. Now, this graph, we can look at it. There's only going to be positive territory because we are going to run into the ground, and we can't go through the ground. So positive is going to be between 0 and 9 seconds. All right, let's look at letter B. We have a table. Ashley has received a gift card to the movie theater for her birthday. The table shows the amount of money remaining on her gift card Y after X trips to the movie theater. Identify the X and Y intercepts of the graph and interpret meanings in the context. So we're going to start with our y-intercept. Y-intercept is when x is equal to 0. So our y-intercept is going to be y equals $90. And that is the money to start on the gift card. Our x-intercept is going to be over here when x is equal to 10, and that is going to be 10 trips for the balance to equal 0. So after 10 trips, she will have no money left on her gift card, assuming she spends the same amount every single time. Letter C. The table shows Violet's lunch account balance over a number of days. Identify the x and y intercepts of the graph and interpret meanings in the context. So again, let's start with our y-intercept. Our y-intercept is when x is equal to 0. So our y-intercept for this case, we have $150. And this is the starting balance on her account. All right, now if we look for our x-intercept, it's going to be right down here at 40. Our x-intercept is going to be x equals 40, and that's going to be days. And our meaning in the context is that in 40 days, lunch money runs out. Okay, in 40 days, the lunch money is going to run out. Now, I want you guys to do letters D and E on your own and then check them against my work. Letter D. We have the graph showing the population Y of birds X years after they were brought to an endangered species park. Identify X and Y intercepts of the graph and interpret the meanings given the context. So our y-intercept is going to be at that point right there. So our y-intercept is 50 birds. And this is the starting amount at the park. Starting population at the park. And our x-intercept is going to be right here, and it's 8 years. And the context is when the population reaches 0. So for whatever reason, the population of birds has decreased to 0. Maybe they've been rehabilitated and released to the wild. Maybe the bird has gone extinct. We don't know. We just know that the population in this particular park has gone to 0. Letter E. We're going to identify our y-intercept and x-intercepts again. And we have a graph showing the number of people at a gym over the course of the day, and we want to write what is the context of those intercepts. So our y-intercept is going to be right here at the start, which is going to be y equals 20, and we're measuring that in people, so 20 people. And the context here is we have people at the start of the day. So when the gym opened, there were 20 people there ready to get their swole on. So now what is our x-intercept? Our x-intercept is over here at x equals 12. And that is measured in hours. And this will be the time the gym closes. And we can interpret that as when the gym closes because everybody leaves. There is nobody left in the gym at that point in time. So that is interpreting that as when it's closing. Now, as we've worked through these questions, we have come up with a lot of the same word that's coming up in all of our y-intercepts, and it is the word starting. So a y-intercept, and especially as we start to think of writing equations in slope-intercept form in the next couple weeks, your starting point, your y-intercept is your starting point. It is what you have at the very beginning, and then something is happening to the graph to either increase, decrease, or change in some way, shape, or form the amount of whatever it is that you're measuring is going to happen. So starting value is really a good word and a good way to think of what your y-intercept is. It is your starting value. It's your starting point for whatever you're calculating or whatever you're graphing, because starting points using a y-intercept as a starting point is a really strong way to graph. All right. So if you have any questions, please bring them to class. Otherwise, have a great day.